Hi everyone, welcome to a onboard to Azure with John session. I'm playing around with the name. The other option was get bored with John. I thought I'd go with the former, but by the end of this video you may want it to be the latter. So in this session I want to talk about resiliency in Azure, because I think it's a really important topic that I don't think is always fully understood in terms of what are your responsibilities as the customer, as a person utilizing Azure, and what is done for me automatically as part of Azure. I think sometimes there's this thought that, well, if I deploy to Azure, I don't have to worry about resiliency, don't have to worry about backup or disaster recovery. It's just done for me. It's in the cloud. Cloud's everywhere. And that's not the case. For most services I deploy to Azure, I absolutely have to think about resiliency, high availability, disaster recovery, backup. Now, that doesn't mean there aren't technologies in Azure to help do this. There absolutely are across all of the different technologies. But I need to architect those. I need to deploy them. They're not just done for me out the box. And I think the easiest way to think about this is kind of start from the ground up, how we think about services, how we think about deployment, how we think about Azure. So ordinarily, if we ever think about infrastructure, applications, there are layers. And often we think about there is storage, there is network, then there's compute services like the servers. And then on top of that physical fabric element, there's things like a hypervisor. And then we get these virtual machines. So in that virtual machine I have an operating system, maybe I have runtimes and middlewares, then I have my app, and then I have my data. So these various things I care about. Now, on premises, we're responsible for all of those. We think about caring for all of those things. Now, how does that shift when we think about the cloud? So there's different types of service available. Now, I'm going to start with, though, let's just draw in some Azure regions. So I'm going to draw each Azure region, in this case, as a separate little cloud. So there's one Azure region, and here's a second Azure region. They could really be any kind of regions you want. For argument's sake, we could kind of say, well, this is East US, and this is West US, but it really doesn't matter. So I have two regions. Now, when I think about the types of services in Azure, we often kind of draw lines of responsibility. So I can think, well, if I draw this line between the hypervisor and the operating system, this is what typically we would think as IaaS, infrastructure as a service. What I get is a virtual machine. I don't worry about the physical fabric. I don't worry about the hypervisor. But inside that virtual machine, I'm responsible for everything. And then we have this other layer where we think of platform as a service. Now, there are some sort of gradients between here. We think of things like app service plans, serverless compute like Azure Functions and Logic Apps. There's also container services that may kind of be a little bit gray in exactly where that delineation is, but that's kind of the main idea behind it. And then, of course, there's software as a service. Now, software as a service is kind of above all those things. If I think about something like Office 365, I'm not managing the application. I'm not really managing the data even. I deploy the service, and pretty much everything's done for me. It's fully managed. And this is kind of an important point, because we want to think about, well, what's actually happening behind the scenes for these different types of service? And when I think about who is responsible, when I think about availability, disaster recovery, take a step back and think, where do I deploy? So if I deploy an IaaS virtual machine, well, the object I create, I deploy to a region. So I deploy my virtual machine here. I pick a region and I deploy it. If I deploy PaaS services, like an app service plan, a Kubernetes cluster, pretty much all of them, I deploy it to a region. So I go ahead and I create my app service plan. I create my AKS service, but it's to a region. Now, if I deploy a SaaS service like Office 365, well, I just deploy it to a geo. So in this case, it's kind of its own cloud that I don't really worry about specific regions and data centers. That's just done for me. So this is an important point. When I'm deploying virtual machines, PaaS services, pretty much all of those constructs, I'm targeting a region. So that's kind of a good indication of what that kind of resiliency boundary is. Now let's drill into one of these for a second. So let's look at a region, and let's explode this out. So if I think about behind the scenes, there's no magic to how these things kind of work. A region behind the scenes is essentially made up of a number of data centers. And for some regions, and that's expanding, I would kind of see these as availability zones. Isolated cooling and power and communication. And in my subscription, per region, I might see kind of an AZ1, AZ2, and AZ3. So I can think about in terms of a blast radius, the impact that's possible when I deploy it to an availability zone. Well, if something impacts that entire availability zone, if I've spread my deployment over multiple availability zones, I'm resilient at a data center, at an availability zone level. So if my deployment, this could be a virtual machine scale set, this could be app service plans, and this could be individual virtual machines that I've put together. If I deploy my service across different availability zones, in terms of resiliency, I'm resilient against an entire data center failing because my workloads have been distributed over really 3 different availability zones. So my blast radius I can survive is something happening at a data center level, this isolated building. Now within those data centers, there's actually racks and racks of servers. And what I could do is I can create something called an availability set. So an availability set, so I'll just call it AS. When I deploy things to an availability set, by default what it's going to do is distribute my workloads in a kind of a round-robin fashion across 3 fault domains. So I can think about a rack as a fault domain. So fault domain 0, fault domain 1, fault domain 2. So I've got now resiliency. If I use availability sets, my blast radius, what I can survive is a rack level failure. Could be power supply in the rack, could be top of rack switch. But my workloads are now spread over different fault domains, different racks within that one data center. So I can survive a node or a rack failure, my service will keep running. If I lost the entire data center, I've lost my workload. So in terms of resiliency, availability set is good. I'm protected from a rack failure. Availability zones, I'm protected from an entire facility, a data center failure within a region. And across all these services, typically there'll be a load balancer front-ending the services, so it's kind of a single endpoint to them. So that's kind of a very simple when I think about resiliency within a region. So we think high availability. For high availability, when I deploy, I need to make sure I'm using availability sets or availability zones to spread my workloads over a certain blast radius. For things like app service plans and Kubernetes, clusters, most of them, it's going to automatically leverage either sets or zones. Some of them you can pick. It depends on the region. Not all regions have availability zones yet. So I would pick the one I want, but this is high availability. And when I think about what is a region, really we think about a region as a 2 millisecond latency round trip envelope. So these facilities could actually be 10 miles apart. but the latency for that round trip is going to be 2 milliseconds or less, and kind of that's the key point to that. So I think high availability, sets or zones. And don't forget about backup. Backup is still critically important. Just because I've got high availability doesn't mean I don't back up. Backup is good if there's a corruption, if I need to go back to a previous point in time. So I still need backups. That doesn't go away. So that's high availability. We make sure we use these, make sure we put kind of like load balancers here that would distribute the traffic to back-end sets for zones or sets. But now I have to think about, OK, well, that's fair. That gives me resiliency within the region. So that's probably going to be a hardware failure type event. But what if there's a region-level problem, a natural disaster, something like that? So now we have to think about disaster recovery. So for disaster recovery, let's take a step back for a second. And let's think about what we would do on premises. So on premises, we normally break it down into layers. And I can think, once again, well, there's storage. There's maybe a hypervisor. There's the OS. And there's the app. And on premises, I probably have these same layers available on the other side. Some companies, for their disaster recovery, they replicate the storage level. SANS do an SRDF, for example. I might use the hypervisor, Hyper-V Replica. ESX has its own site recovery manager technology as well, so I could replicate at this level. I could have some kind of in-guest agent. So I could replicate at the operating system. For Windows, I might use Storage Replica to replicate data volumes. Or I might replicate at the app level. If I'm using, for example, SQL Always On, availability groups, if I'm using Active Directory multi-master replication, I can replicate at the app level. And typically, the higher up we go in this stack, the better. If I think how quickly I can recover, how much data I'll lose in an unplanned failover, this is going to be the best one. I probably will lose almost no data in an unplanned, maybe a few seconds, and I'm going to be up and running very, very quickly. Whereas at a storage level, it doesn't really understand the data. It's probably going to start in a crash consistent state. Don't know how much data I've lost. And it might get a little bit better as I go up the layers. So this is going to give me the best experience. Now, I could extend this if I was going to use Azure for disaster recovery. So now suddenly we've got Azure over here. And we think of it exactly the same way. Storage, not so much. Hypervisor, yes. I can replicate from the hypervisor to the cloud with Hyper-V. So essentially what happens is now it's going to replicate up really to storage. It's going to populate virtual hard disks. So I'm going to pay for an Azure Site Recovery license and the storage, but there's no compute running. There is no server running up here that I'm paying compute charges for. I could replicate at the operating system level. I would do this if my source was ESX, if it was a physical box. And here the way this in-guest works is if you think about kind of, well, I have the application, I have the file system, I have kind of a volume driver, and then I have the actual disk. What the OS level does is it inserts this kernel mode driver between the file system and the volume driver. So as writes go down, it fractures that write, and it copies it to the cloud. Once again, it's an Azure Site Recovery license. So is that. I'm not paying for any compute charges. So I could use that to the cloud. Or I could replicate the application. Now here's where it's different, because to replicate for the application, well, I'd actually have to have a VM running, I'd have the app installed, and then I could replicate app to apps. This could be SQL, could be Active Directory multi-master replication. Here I'm paying compute charges, and obviously it still needs a disk. So different options. This is going to give me the best performance, but it's going to be priced very differently, because now I'm having to pay compute all the time. So that's just a really quick background. My focus for this video is not about DR to Azure, but these concepts actually flow the same way. So if we go back to our cloud view, if I think about disaster recovery, well, I kind of have the same options again. If I think about, well, I have this virtual machine, I can absolutely replicate over to another region to a disk. And this essentially is Azure Site Recovery. Or I might pick, well, actually, I've got the app running in here. I'm going to create a virtual machine over here. I'm going to install the app, and I'm going to replicate at the application level, for example, SQL. But again, the price is going to be very different. This compute charge is now running all the time, and of course, it still needs that VHD. So that there's going to be a different concept there for that. What about other services? Say like an app service plan, we're not going to replicate that. Yes, we could also deploy our application to an instance over here, and it could be ready. I might have other services like SQL, Azure SQL Database, Azure Cosmos DB. They just have replication options. So I can just set up, hey, I need a replica in another region. And for SQL, I'd have this read-only replica. For Cosmos DB, it's multi-master. I could read to that as well. What I don't care about is something like Office. That's just done for me. That's part of the service. So that's kind of a nice thing. So step back, availability, sets and zones. That's my responsibility to make sure I'm architecting that. So things like app service plans, it's going to do that behind the scenes. Things like SQL, it's going to do those things behind the scenes. The only thing I have to make sure I do for app service plans is to have at least 2, ideally 3 instances as part of my plan so it can distribute. Then I think about disaster recovery. Well, because I'm deploying to a region, I have to put something in place to have a DR story. So for virtual machines, I could replicate kind of at the Azure level. So it will replicate the storage, no compute charges until I fail over. Or if it's maybe a really critical workload where I want more control over that replication, I want it to start up faster, I can replicate inside the app. But now it means I have to have the VM running on the other side, so the compute charge will be higher. I don't have to pick one. We're going to have something called a recovery plan. A recovery plan brings all these things together. It will orchestrate, give me a big red button that I can push when I want to fail over. And it can fail over virtual machines, it can fail over applications, it can run automation scripts through PowerShell, I can go Azure Functions. I've got a lot of flexibility there. So I can bring all of these things together. So don't think I have to settle on one technology. Use the right technology that meets your recovery point, your recovery time objectives for each workload. Because cost is important here. I don't want the very best of everything and replicating everything if I don't need to. Is this disaster recovery? For the services that have a state I care about, it's really important, that SQL database, sure, I might want the best possible option. And for things like SQL database, the Azure SQL database, this is really easy. Also think about, does it have any state? And what I mean by that is there anything inside that virtual machine that's particularly special that I care about? Or could I just recreate it? Because I might have a whole bunch of virtual machines. I might have 10 IIS web front ends, or Apache, or Linux, whatever. They're just running some stateless thing. Why would I bother replicating 10 stateless things? I probably created them using some declarative technology like PowerShell DSE or Chef or Puppet. I might have that config in a repo, Azure Repos, GitHub, whatever. It might be a VM scale set. So rather than paying to replicate, as part of my recovery plan, as long as that repo is resilient and available, or I have that gold image, in the case of an actual failover, well, I pull that in and I create the workloads. It takes a few minutes. There's no state. The state's in that database. So don't pay to replicate something I really don't care about. I can just create it as I need it. And of course, when you think about disaster recovery, I have to think about failing things over. So you're probably going to have some kind of geo-balancing solution on top of this. Traffic manager, front door. I'm going to cover those in more detail in a future video. But don't forget about that. I have to fail people over. It could be a DNS entry. Then I have to think about the time to live, how long that value is cached for, because the public IP addresses will change if I move from one region to another. I can't take a public IP from one region and then leverage it in another region. It is going to change. Okay, so I can think about availability, disaster recovery. We've not forgotten about backups. Backups probably want those geo-replicated. I can always restore from a backup as well. Recovery plan brings all these steps together. Is this the right answer, though, this disaster recovery? Having this active and then failover. We're used to that on premises, because on premises we tend to have a main data center, and then we have some DR facility that probably not that great. We're not really sure it's going to work, but we can say we have DR. But we're really, really hoping we never use that thing, so it's probably not going to work very well. In the cloud, we have these Azure regions that are just available to us. So we might change our thinking a little bit. So if today in a region, I probably have a multi-tiered application, and I've probably got some database. Just take an example here. And let's say this is Azure SQL DB. And I've got some set of front ends, N number. And they've got some load balancer in front of them. They're distributed over availability sets or availability zones, and this balances the traffic, and it has this public endpoint. And now I want DR. So I can think about, okay, I have this other cloud, and either through a replication. So I've got a SQL DB. It's kind of read-only, though. It's a secondary. And then a disaster. Well, the database is replicating. The front ends I can pull from that repo and recreate if I need to. But why do that? I might have customers that are over here, customers in Europe, customers in Asia. So why just have this one active region? Why not? Let's imagine I have a whole bunch of instances here. Why not? Let's take some of them, and take 3 of them, and stand up 3 over here. It's got a public endpoint as well. I'll have some geo-balancing, front door or traffic manager, depending on, I'd use front door if it's HTTP or HTTPS. I'd use traffic manager if it's anything else. And now I'm balancing between them. It's costing me basically the same. I had 6 instances here. Now I've got 3 here and 3 there, so my compute charge is basically a wash. There might be a bit more now through this geo-balancing. I needed this replica anyway. But there is a challenge now. This works great for the front end, but remember, the front ends are talking to the database. SQL is not multi-master. I can only write to one of them. So these instances over here, well, they're a little bit stuck. Now, one option is they come here for all their read and writes. But there's a latency issue here. There's a speed over fiber, which is slower than the speed of light. So there's going to be a latency introduced. It really depends on this application. Now, one thing I can do is there's a SQL read-write listener. So I could say, look, when I need to write, my writes, sure, my writes have to go to the master. So I'm going to target that read-write listener. But my reads, which is most of my workload, I'll specify my local copy. So I'll do my reads from here. Now this requires some changes on the application, because the application now has to differentiate. It also has to think about, if I just did a write, and then I want to read that back, well, I'm going to have to go to this one, because this may not have replicated back yet. So I'll get an inconsistency. But if I do a little bit of re-architecture, this might work. If my app is mainly reading things, and I can tolerate a bit of latency on the write, this is a very common pattern to use. So now I've moved from having disaster recovery to I'm active-active. If one of these regions died, I'm running already. Now I would have to flip a switch to now make this the primary. So now the read-write listener would move to here, and I would start leveraging this one. I'd lose scale, because I've gone from 6 total instances to 3. Well, I could automatically scale that out to 6. So this is a really nice solution. But it does require this to be allowed. What if it isn't? Well, if I have to be able to read-write locally for performance reasons, then I'm either, this has to just be passive. All of the active is here, and I would actually have to fail over, make this master, make this the active set, move the balancer to point to here. Or I change my data technology. Because my other option is if I think about multiple regions, and I think about, yep, I have those instances at the front, I've got my same load balancer, I've got my instances here, and I've got my load balancer. I'm not going to use Azure SQL Database. What I'm going to use is Cosmos. Now, as a Cosmos DB is a sort of a document-based, it supports different types of models, different types of interfaces to it. But what I can do with Cosmos DB is I can set up replicas wherever I want, and they are multi-master. So what that means is changes replicate between them, and I can read-write to my local copy. Now, CAP theorem still applies. I still have to kind of pick 2 of like consistency, availability, partitioning. But what happens is I have a session, and the default consistency level for Cosmos DB, because I can select this, I can set to be strongly consistent. It basically has to replicate across all of them before the write is accepted. It can be eventually consistent. Just write it. We'll get there when it gets there. Session consistency is kind of the one in the middle. It's most commonly used. The read-writes will guarantee to be in the same order within a session. So all of the apps within one region would share the session key, so they'd always get consistent read-writes. Now, eventually it would replicate over to the other sides, but I'll have consistency within each region. Now, this is a major rewrite. My application is changing how it deals with data, how it accesses the data, but this would cure that problem. And of course, I've still got that geo-balancing at the top, traffic manager front door, but this is another model. So we covered quite a lot of stuff. It's just different ways of thinking about it. But the critical thing is, take a step back. What am I deploying? If I'm deploying PaaS or IaaS, when you're deploying that resource, if you're specifying as part of that deployment a region, you are deploying to a region. That's all you're doing. There's no built-in DR to that thing. I have to think about availability to that deployment. I'm using sets or zones, depending on my blast radius. I make sure I have backup as part of the solution as well. And then I think about disaster recovery. I can think about, for the virtual machines, if it has state that I care about, hey, I could replicate at the VM level, Azure Site Recovery. I could replicate inside the application, realizing I now need compute services to run the app at the other side. So it's going to cost me more, but I'm going to get a better recovery point, a better recovery time. If it's a PaaS service, I could deploy the app service plan to multiple regions. Things like SQL, I can just add replicas. Cosmos DB, I can add replicas. So there's technologies to do it for me, but I just have to turn them on. I have to architect them. So that's high availability. That's DR. I have that geo-balancing between them. If it's SaaS, I don't care as much. That's the responsibility of the service. But can I change the way I think about it? Ideally, I don't want active-passive. I want to go active-active. It does require me to think about how I handle the data. If I'm using SQL Server, be it Azure SQL Database or SQL running in IaaS VMs, it's single master. I can only write to one of them. So now my app would have to do something different, either handle the latencies for all the reads and the writes, or handle latency for the write, but read from my local. Or I re-architect and I move to technologies like Cosmos DB. I hope this was useful. My main point of this is just to stress you do have to think about high availability. You do have to think about disaster recovery. There's a ton of technologies in Azure to help you with that. You just have to pick the one, architect it. Remember, things like recovery plans can help with that failover process. Automate everything, just give that big red button that you push to do that. Don't forget about backups. You still need those, so I can roll back if there's some sort of corruption or something else. Let me know if you think this should be all aboard to Azure with John, or get bored by John. But take care, everyone. Thank you.